Hey everyone, welcome back. So in this video, we'll be beginning with DHCP. First of all, we'd understand what exactly is DHCP, and then we'll continue on understanding how it works. So let's start right away. All right, guys, so we're beginning with DHCP. We're covering DHCP. Now, this is an acronym for Dynamic Host Configuration Protocol. Okay, so what happens is that whenever a system uses TCP/IP suite, okay, so whenever a system uses TCP/IP suite, it needs some sort of configuration. Some configuration is needed. Okay, that means we need some information for using TCP/IP. So that information includes, first of all, the IP address. Okay, so if a system wants to use TCP/IP suite, then it needs to have a IP. It needs to have an IP address, right? Because all of the protocols rely on the IP address, right? So we would need the IP address. Next up, if it's part of a subnet, then would need subnet mask, right? We would need the subnet mask. Next up, what other things that a system might need is default address of a router. Okay, so to reach from source to destination, we need to go through this device called router, right? So we would need the address of that router to continue our communication. Last, what we need is address of the name server. Okay, so this is a term which is a topic in itself that we'll be discussing later. But for now, you can understand that name server is used for mapping. Okay, it's used for mapping from name, domain name to address, and from address to domain name. Okay, so in case our system needs to map name to address or address to name, we would need name server. And for that, we need address of name server. Okay, so all these informations are provided by DHCP. Okay, so what exactly is DHCP? It's a network management protocol. It's a network management protocol that dynamically assign IP address to a system. Okay, so what we mean by the word dynamic would be explained later, but for now, to give a simple definition of DHCP, it's a network management protocol that assign IP address to a system, right? That dynamically assign IP address to a system. Okay, so what happens is, let's suppose that we have 3 nodes in our network. Okay, so there are only 3 nodes and it's a small network, of course, right? So if network administrator wants it, he can go to each of these systems separately and set them some IP addresses manually, right? And give them some IP addresses. So it is possible with 3 systems, but if the systems were 300, then our network administrator cannot do this manually. It will be very impractical of him to do that, right? So for that, we have DHCP. It automates and manages configurations of system. Okay. So this process is automated. The thing that network administrator would have done manually, he would have gone system to system and changed the configuration. Instead of that, we are doing this process in an automated form, right? And that is done with the help of DHCP. Okay, so let's understand what is the DORA process. Okay, so that's very important part of our DHCP. So this is DORA process. Now this stands for, this is an acronym for discover, offer, request, and acknowledgement. Okay, so this is how DHCP client and server communicate. Okay, yeah, I forgot to mention DHCP is a client server protocol, right? It's a client server protocol. Okay, so what happens is initially client sends a discover message to DHCP server. Okay, so at this point we're trying to discover the server, right? We are saying that we are in need of IP address. We do not have an IP address. We do not have an IP address yet. Please send it that to us. Okay, so we are trying to discover our servers. So this is the first step. Okay, client sends some discover request to DHCP server. Okay, now DHCP server receives this request, sees that client is in need of IP address. What it does is it finds one IP address. Okay, so detailed processing is something that we'll be studying we'll be studying later. Right now, just let's understand briefly how these processes work, right? So server would find some IP address and it would offer that IP address to client. Okay, it'll say that, yeah, this is the IP address that I'm offering you, right? So offered, IP address is offered at this point. Now this response is received by our client. Okay, so client sees this IP address and client then requests that I want this IP address to be assigned to me. Okay, so client sends a request that assign this IP address to me. Okay, server, what it does is it first of all assigns the IP address to client, right? It assigns IP, it assigns IP and then sends an acknowledgement back that yeah, I have assigned this IP address to you and now it's yours. Okay, so something like that. So this is our DORA process, how we're communicating from client to server. Okay, so it's a client server model. Now in this, two cases can happen. First is that client and server are in same network. Okay, this happens very rarely, but a network administrator can do that. Okay, we can keep client and server both in the same network, right? Other case would be that they are in different network. Okay, so we'll have to discuss each of these cases separately. Let's start with that. All right, guys, so let's discuss first case first. So client and server are on same network. They're on same network. Then what would happen? Okay, so this is our one network and we have client right here, right? Client, which is waiting for an IP address. It needs an IP address, and server, which would be providing an IP address, right? And they exist on the same network. Okay, so like we discussed DORA process. Okay, so out of this discover and request comes under request type of messages. There are two types of messages, request or response, right? Either you're requesting for something or you're responding to a request, right? So discover and request are request type of messages. Now offer and acknowledgement are response a response type of messages. So our client requests and our server responds. Okay, so coming to discover. Okay, so we'll generate a discover message. We'll generate some discover packet, the format of which would be discussed eventually. So a packet is generated at application layer. Okay, so as we go from application layer to transport layer, we'll have to encapsulate this packet in a UDP datagram. Right? So in UDP datagram, this packet is encapsulated. Okay, this packet is encapsulated here. What else we add? Source port, not S. Okay, so wherever we're using S, it's for server. Okay, so let's not confuse that. So we have source port and we have destination port, right? Destination port. Okay, so in case of UDP, the two ports that are used by client and server are client uses port number 68 and server uses port number 67. Okay, so since we are sending things from client to server, so right now source would be 68 and destination would be 67. Okay, now as we come from transport layer to network layer, now we've reached network layer. Okay, so in this UDP datagram would be encapsulated in IP datagram. Okay, so this is our UDP segment encapsulated here, and we have to add two new things. First is source address, again not S, source address, right? And we have destination address. So we have two addresses, right? So source address, client does not have a source address yet. So we would put all zeros. Client does not have a source IP address. That's an typo and that's what we're asking for, right? Now for destination address, client is not aware about server's destination address either. Client does not know destination or server's IP. Server's IP. So what we do in these cases, we create a broadcast message, right? So it'll be a string of all ones. That means it's a broadcast message. Send it to everyone. Okay, so something like that. So if we can see this here, so we have this packet encapsulated, right? This is DHCP request. Next up, we have a source port and destination port. So source port is client port in this case. We are sending from client to server. Destination is server port. 68 and 67 we just discussed, right? Next up, this is client IP and source server's IP, right? So client's IP was 00 because no IP is given yet, and destination's IP or server's IP is 11 because it's a broadcast message. We do not know server's exact IP address. Okay, so this message is sent, right? This message is sent and it is received by switch. Okay, now switch sees that this message is broadcast. It's a broadcast message. Okay, and so what it does is it simply sends this to all ports. Okay, sends it to all ports. Okay, so if we can erase some of it so that we have cleaner things, right? Okay, so it's a broadcast, so we send this to all the ports. Now at port number 67, our server would be waiting. Okay, so server would receive this information, right? It will receive the information. It will find out that a discover request is sent to it. Discover request is sent to it. Okay, so it will find some IP address, how that we'll be discussing, but some IP address is found, right? And this IP address is then sent back to our client. Okay, then same procedure will follow. That first of all, we'll have a packet, then we'll make it a UDP datagram, then we'll make it a IP datagram, encapsulation of all these, right? So at the end of the day, our source IP address would be servers because now we're sending from server to client. So source IP address would be server's IP address. Now server's IP is known by server itself, right? So we can provide the server IP here. Next, we want to send to client. Again, we will be sending a broadcast message, right? So because still like we are offering IP, we do not, we haven't assigned the IP, right? So broadcast message. Next up, we'll be giving source port and destination port, right? So source port would be server port 67, destination port would be client's port, that is 68. Okay, and reply, that is offer in the first case. Okay, so this is how things happen when we are dealing with when we are dealing with the client and server on the same network. Okay, our next case is when client and server are on separate networks. Okay, so let's see that. All right, so let's quickly discuss our second case as well, in which client and server are on different networks, right? Are on different networks. Okay, so in this scenario, as you can see, is that this is DHCP client and it's on LAN number 1, and this is DHCP server which is on LAN number 2. Okay, so there are different networks, right? Now, for request for a message to reach from source to destination, where source and destination are both on different networks, we need a device called router in between. Okay, so we need router in between for a message to reach from source, which is on network number 1, to destination, which is on network number 2. Okay, so when devices are at different networks, we need some mediator device in between, that's called router, right? So we'll be needing router in between. Okay, so what happens is, let's go through the process like we did in the last case and see where it varies, right? So first of all, simple, we create a DHCP request. DHCP request, it's a packet, right? We encapsulate it in UDP datagram. So it's encapsulated. We have source port and a destination port. Now, client port is same 68 and destination port is or the server port is also same 67, right? So we'll add those values 68 and 67, source and destination, right? Now this is further encapsulated into an IP datagram. This was UDP datagram. This is IDP datagram. Sorry, UDP, IP, right? So this entire thing is encapsulated here. We add source and destination address. Source address, since we do not know source address, all zeros. and destination all ones, right? All ones because we are not aware about DHCP server's IP address. Okay, so we do not know DHCP server's IP address. As a result, we are sending a broadcast message to each and every one. Okay, and we're hoping that it will reach the right server. Okay, so this is how our IP datagram looks. Now here is where the problem lies. Okay, so what happens is that router, it discards datagrams that are broadcast. Okay, so router checks when the destination address is found to be broadcast. The broadcast address is a limited type of addressing. So router does not allow it to go to other networks and it just discards it. Okay, so router discards all the datagrams that have broadcast address as their destination address. Now, if router would discard this, then it would never be able to reach the server and we would never get the IP address. So to avoid this, what we do is we add another component, right? So we add this another component and we call it relay agent. Relay agent. Now, I guess you guys would be familiar with the concept of relay races, right? We have this track and multiple members of one team are participating and they're located at different locations, right? So one person starts from here, another is waiting right here. Okay, so this person runs till this location where another person is waiting, passes on the baton. Like suppose P1 came from here to here, P1 reached here, P2 was waiting here. So P2 would take the baton and would go on for the rest of the race, right? P2 would go from here to here. Okay, so something like that's happening. So what's happening is that at an intermediate location, message passing is happening, right? Message is taken by from P1 to P2 and P2 takes it for rest of the way. Okay, so something like that would happen in our case as well. So here's our client, and here's our relay agent, and here is our server. Okay, so initially what happens is that our client creates a broadcast message. Okay, it sends a broadcast to everyone and relay agent is waiting on port number 67. So what was the port number in UDP datagram for destination? It was 67, right? So at port number 67, relay agent is waiting and it will get some message, right? It will get that DHCP request. Now this relay agent has one great thing about it, that it has the DHCP server's IP address. Okay, so DHCP server's IP address is present. So what happens is we get that address and instead of sending a broadcast message, we send a unicast message. Unicast message specifically to our DHCP server because we have the IP address of DHCP server. So we will convert the broadcast message into unicast message. Now router would not discard this unicast message and it would send it to the server. Okay, so server receives this DHCP request. Again, the same process happens that it decapsulates it. It receives the request and then it creates the response. Some response would be created. Again, the response is given to a relay agent and that relay agent further passes on to the client. Okay, so this is what happens in our second case. Okay, when client and server are on the different networks. All right, so this is it for this video. In the next set of videos, we'll be understanding the remaining concepts of DHCP.